Hello friends, welcome back, and in this video we are going to discuss about generating the probability distribution, the distribution of the data, based on the probability. Okay, so let me first import Numpy as NP, and then we have from Numpy import random. Okay, so I have to generate a probability distribution of certain numbers. Suppose I have this set of numbers. Let me generate it. Array is equal to it's like random dot choice. Okay, so this will be something like among these numbers like 1 3 4 1 4 5 and 7. I want to generate these numbers based on certain probability. So for that, I need to give the probability, and that is represented by P. So the next argument after this set of values, the next argument will be P, which will be the probability, and I have to define the probability for each of these values. So the probability of these values will be mapped accordingly, right? So for the the probability I'm setting here is 0.5. For 4, I'm setting like 0.1, and then for 5, I'm setting like 0.4, and then it's like 0.0 for the 7. So probability of generating 7 is 0, probability of generating 5 is 4, probability of generating 1 is the highest, right? So 0.5 is the probability for that one, right, which is 50%. So one thing you need to remember, that whenever you are defining the probability here, whenever you're giving the probability here, then that the sum of all these probabilities should be 1. So here you can see like 5 1 6 4 10, right? So this becomes 1.0. So 1 should be the final probability after the sum, which whatever you are providing here in this particular value, right, the probability. And now how many numbers we want to generate? So size I'm going to give here like 20. So I want to generate 20 numbers among these numbers 1 4 5 7, and the probability for each of the numbers I have provided in this variable P in the next argument, and based on this will generate the probability. See, the sum of all the probability distributions here, like the probability 0.5 1 0.4, the sum should be 1 because the maximum probability is 1, right? The maximum probability is 1, and here we are going to distribute certain values. We are talking about the distribution of certain values, right? Suppose there are some events like you throw some coin, right? You throw some coin 3 times, right? When you throw that coin 3 times and you are trying to get the head, the number of heads, whether it could be 3, whether it could be 0, whether it could be 2 or 1. These are the possibilities. So all these possibilities has certain probability. So the sum of all these probabilities of getting a head, 1 2 3 or any head, that probability comes out to be 1, right? So these kind of probability functions are known as the probability mass functions. What are they? How they work? For that we have a separate playlist on the probability, which is there in the same channel, and there we have discussed about the probability and that mathematics for the data science, something like that. I have created that particular playlist. I have created. You can go there and you can understand about the probability mass function. So there you will understand the same example of having the 3 coins, having 1 coin thrown thrice, and then we calculated the random variable value and its probability of getting 1 head or 2 head or 3 head or no head at all. So all those possibilities we have given there and we have understood there, and the sum of all the probabilities have become 1, right? So based on that we call, if any of the probability function, any of the probability experiment follows the path like all the probability sum is 1, then in that case that particular probability function, that particular probability experiment, whatever function can define that particular experiment, that function is known as the probability mass function. So this is the probability mass function in case of discrete variables. What are discrete random variables, that we have discussed there. Whatever are the continuous random variable, that also we have discussed there, so that you can check there. Okay, so random dot choice 1 4 5 7, P is equal to 0.5 0.1 0.4 and 0.0, size is equal to 20. So all this sum is 1, and now we are going to print the array of 20 elements. So let's see what is the output which comes. So here you can see the 5, which is 1, right? So 1 has one came most number of times, 1 1 1 1. So most number of times you can see 1, but you will not be able to see 7 at any point of time. Doesn't matter how many times you will run it, you will not get any you will not get 7 at any point of time, right? You cannot get 7. You will get 4, you will get 1, you will get 5, everything you will get based on their probabilities. You will get their numbers, they will be repeated that number of time, but you will not be able to get that 7 whose probability is 0, because we have defined the probability 0, so you will not be able to get 7. Okay, so this is how the random numbers are generated. So based on the need, you generate these numbers, you create these numbers for creating some sample, all of those things. You to do all those things in your data science model, in your machine learning model, you do need these kind of things to use. So that is why this generation of these random numbers based on the probability is needed, right? So this is for generating the one dimensional array of numbers, 20 elements. And suppose at some point of time I want to give size equal to I want to create I want to create an array, a two-dimensional array of 12 elements, where 3 by 4 or 3 by 3, let's say we want to create a 3 by 3 matrix of these values. Then in that case we can give like 3 and 3, and now we need to run it. So now you can see 9 elements have been produced among these numbers 1 4 5 and 7, and you can see 7 has never come here, and 1 has came here most number of times. 4 number of times 1 has came, and then 3 number of times 5 has come, because the second number of probability is for the 5, which is 0.4, and the third number is for 4, so 4 has come only 1. Okay, so this is how the random numbers can be generated in the probability distribution format, and based on the their probability. Okay, so this is how you generate it, and based on the requirement you can keep generating these in your for your machine learning model. So in more detail we will keep discussing in coming videos, and there is another playlist there on the same channel which is related to data science, mathematics for the data science, something like that I have created. So you can go there. There are at least 3 to 4 videos as of now which are related to the probability and the distribution, so you can go there and you can understand it more clearly. Okay, so with this I would like to conclude this particular video, and in the next video we'll meet soon. Till then, have a nice day, and bye bye. Thank you.